Say we have a suitcase that is being dragged on a surface with friction. We want to know the coefficient of friction, and the suitcase is being dragged by a force, Fp for pull. It's being pulled by a force Fp, and maybe let's make the angle here phi, so we know the angle. It's the angle with respect to the vertical, and the object is moving at a constant speed, v naught, so it's moving to the left, and it has a mass S for suitcase, and we want the coefficient of friction, so we're looking for something that has the symbol mu in our equations. And so this is MA. It's an application of MA equals the sum of the forces, and we need to figure out the forces in the vertical and horizontal directions. So in the vertical direction, we know that the acceleration is 0, so the left-hand side of that is 0. We have a normal force, which is upwards, Fn, that's unknown. We have part of the Fp force in the vertical direction. So we have plus Fp cosine of phi, and then we have the weight of the object, the gravitational force, ms times g. And in the vertical direction, we have, that's the vertical and the horizontal direction. We also have 0 acceleration because the speed is constant, so 0 acceleration in the horizontal direction. And we have Fp sine of phi in the horizontal direction to the left, so really this is a negative, if that's the convention we use. And then we have a frictional force to the right, which to the right normally is positive, so we'll do plus mu Fn. And so we see that we want Fn, and once we have Fn, we'll be able to figure out mu. So from the first equation, we will get Fn. So Fn is equal to msg minus the vertical part of the Fp force. And in this equation now, we can say 0 equals minus Fp sine of phi plus the unknown mu times the Fn, which is this, msg minus Fp cosine of phi, and we'll solve for mu. So mu will be Fp sine of phi over msg minus Fp cosine of phi.